Hello students, welcome to Siddhapur Mathematics Academy. So already we started with the applications of derivatives. In the last classes I completed derivative as a rate measure and increasing decreasing function. In the today's class I will start with the tangents and normals. So before going to the examples I will give the basics. See, this is the y-axis, this is the x-axis, and if you draw the curve, any curve, y is equal to f of x, if you draw the curve and a line, straight line which touches the curve at one point, this line is called tangent. This line is called tangent, and a line which is perpendicular to that tangent, is called normal. And I did the figure at the point of contact. So this is a normal, and tell me then what is the relation between tangent and normal? Tangent and normal are perpendicular to each other. Now I am giving you a basic formulas how to find a tangent and normal with the help of derivations. See, y is equal to f of x be any curve, then dy upon dx at the point, that means at point of contact, at the point x1 y1, and this right side is f dash of x, is called slope of the tangent. Slope of the tangent. That means generally it is denoted by m. That is, m is equal to dy upon dx at x1 y1. Understood? That means if you differentiate the given curve, if it is a variable, generally we are taking a variable as a x only. Differentiate the given curve with respect to x and put that values, given values, whatever the answer you are getting, that is called a slope of the tangent. Now we have to how to write the equation of tangent. I am giving you the formula here. Equation of the tangent with slope m at the point x1 comma y1, that means this is the point of contact. At the point x1 y comma y1 is y minus y1 is equal to m in the bracket x minus x1, where m is nothing but dy upon dx at x1 y1. Then next, equation of the normal with slope m at the point x1 y1 is y minus y1 is equal to minus 1 upon m x minus x1. Here also m is nothing but same, it is a differentiation of first differentiation and substituting the value x1 y1, dy upon dx at x1 y1. Reading, you have to read like this, writing is dy upon dx at x1 y1. Now I am giving you one important point, it helps you to solve the examples. Read on the important note. If the tangent is parallel to x-axis, see, already you are familiar. Slope is dy upon dx at x1 y1. In the analytical geometry you are familiar. If the line makes an angle theta, inclination it makes an inclination theta with the x-axis, then the slope is calculated as m is equal to tan theta. If a line makes inclination theta with the x-axis, then m is equal to tan theta. See, if the tangent is parallel to x-axis, means this is a tangent, this is a curve, and this is a tangent. This is parallel to x-axis. Parallel to x-axis means there is no angle with the x-axis. No angle means tan theta. Theta will be what? 0. And what is tan 0? Tan 0 is 0. That means the slope is here 0. If the tangent is parallel to x-axis, so I will give you all the explanation. There is no angle between the tangent and the x-axis. That means theta is 0. Then what is tan 0? Tan 0 is 0. And tan is nothing but slope. Slope is denoted by either like this or like this. That means m is 0 means dy upon dx will be 0. Then dy upon dx is equal to 0. Second one, if the tangent is perpendicular, if the tangent is perpendicular to the x-axis, or you can say that parallel to y-axis. See, this is a curve, it is like this line. It is perpendicular to x-axis, that means angle is what? 90 degree, or parallel to y-axis 90 degree. Tan 90 is what? Tan 90 is infinity, not defined. That means dy upon dx is infinity. Or for our convenient, we can write dy upon dx is equal to 1 upon 0. Please note down these 2 points. This helps you to solve the examples. Now I am going to the examples. I am mixing all worked example as well as exercise. Exercise 6.3. First I will give all the examples related with the slope. Write on the first one, worked example. Find the slope of the tangent to the curve y is equal to x cube minus x at x is equal to 2. So very simple, you have to differentiate once and substitute x is equal to 2. Y is equal to x cube minus x, differentiating with respect to x, dy upon dx is differentiation of x cube is 3x square, differentiation of x is 1, middle minus is there, at x is equal to 2. dy upon dx is 3 into 2 square minus 1. 2 square is 4, 4 3 is 12, 12 minus 1 11. This is nothing but slope of the tangent. Now moving to the same questions in the same category, that is find the slope of the tangent or normal. Now I am giving you the examples from exercise 6.3. Exercise 6.3. First question. Find the slope of the tangent to the curve y is equal to 3 into x raised to 4 minus 4x at x is equal to 4. So the sum is very simple. As usual, first we have to differentiate 1 and write down x is equal to 4. 3 into x to the power 4 minus 4x. Differentiating with respect to x, dy upon dx is equal to 12x cube minus 4. At x is equal to 4, dy upon dx is 12 into 4 cube minus 4. 4 cube is what? 64. It is 12 into 64 minus 4. Multiply 64 into 12. It is 768 minus 4. That is nothing but 764. This is nothing but the slope of the tangent. Yes. Moving to the second question in the exercise 6.3 only. Find the slope of the tangent, second one. Find the slope of the tangent to the curve y is equal to x minus 1 upon x minus 2, where x is not equal to 2. Because if you write x is equal to 2, the answer will be any number upon 0, it is infinity. At x is equal to 10. See, now you understood, no? Slope of the tangent means we have to differentiate the curve once, and whatever the given value, substitute that value. Y is equal to x minus 1 upon x minus 2. Differentiating with respect to x, dy upon dx is equal to x minus 2 u by v method into differentiation of x minus 1 minus x minus 1 into differentiation of x minus 2 whole divided by x minus 2 whole square. It is x minus 2 into 1 minus x minus 1 into 1 divided by x minus 2 whole square. Now simplify this. Dy upon dx is equal to x minus 2 minus x plus 1 divided by x minus 2 whole square. Minus x plus x get cancels. Minus 2 plus 1 is minus 1 divided by x minus 2 whole square. At x is equal to 10. Dy upon dx is minus 1 upon 10 minus 2 whole square. That is minus 1 upon 10 minus 2 is 8. 8 square is 64. This is nothing but slope of the tangent. So understood the concept. The concept is very simple. Differentiate once, and after differentiation, wherever x is there, write down that given value. Moving to the next question. Question number 3. Find the slope of the tangent find the slope of the tangent to the curve y is equal to x square minus x plus 1 at the point whose x coordinate is 2. That means at x is equal to 2. This is the homework question. Fourth one, because simple differentiation we have to do there. Next is x cube minus x. Fourth question, that is also homework. Find the slope of the tangent to the curve y is equal to x cube minus 3x plus 2 at the point whose x coordinate is 3, even though it is also homework questions. Next, moving to the next one, find the slope of the normal. Fifth one, find the slope of the normal to the curve x is equal to a cos cube theta, y is equal to a sin cube theta at theta is equal to pi by 4. See the which type of a question it is. This is a parametric equation. So we have to find the slope of a normal. It is the slope of a tangent or slope of a normal. First we have to find the dy upon dx. So first write down x is equal to a cos cube theta, and they are a parametric equations. We have to differentiate with respect to theta, and already you are familiar with differentiation. Shall I write the steps directly? Dx upon d theta, a constant, differentiation of cos cube is 3 cos square theta into differentiation of cos theta. After covering the power, we have to differentiate the base. It is 3a cos square theta, differentiation of cos is minus sin theta. That's why I am writing in the bracket. This is minus 3a cos square theta into sin theta. Next, y is equal to a sin cube theta. This also we are differentiating with respect to theta. Dy upon d theta is equal to first power 3a sin square theta into differentiation of sin theta. Differentiation of sin theta is cos theta. If you want, you can substitute theta is equal to pi by 4 here, or first you can find dy upon dx. Already you are familiar. Dy upon dx is equal to dy upon d theta dx upon d theta. Dy upon d theta is 3a sin square theta into cos theta divided by minus 3a cos square theta into sin theta. 3a get cancelled, so one sin is cancelled with this, one cos is cancelled with this, and this minus in the bracket, in the numerator sin, in the denominator cos. We have minus tan theta. Therefore, at theta is equal to pi by 4. Dy upon dx is equal to minus tan pi by 4, that is minus 1. If you differentiate and substitute the value, you will get the tangent, slope of the tangent. We are calling it as m. This is the slope of tangent, remember. This is the slope of the tangent, but our question is slope of the normal. So please note down this. Slope of the normal is equal to minus 1 upon m. It is minus 1. M is what? Minus 1. Minus and minus get cancels. M we are getting. Moving to the next question, again related with the same. Find the slope of the normal See the sixth one, find the slope of the normal to the curve x is equal to 1 minus a sin theta and y is equal to b cos square theta at theta is equal to pi by 2. They are a parametric equations. Parameter is theta. That means we have to differentiate with respect to theta. X is equal to 1 minus a sin theta. Differentiating with respect to theta. dx upon d theta is 1 0. Differentiation of 1 is 0 minus a as it is. Differentiation of sin theta is cos theta. Next, y is equal to b cos square theta. Differentiating this with respect to theta, dy upon d theta b as it is 2 cos theta into differentiation of cos theta. Differentiation of cos theta is minus sin theta. Dy upon dx is dy upon d theta dx upon d theta, that is minus 2b cos theta into sin theta divided by minus a cos theta. Cos theta get cancels, minus into minus becomes plus 2b upon a sin theta at theta is equal to pi by 2. Dy upon dx is equal to 2b upon a sin 90 degree. What is sin 90 degree? Sin 90 degree is 1. That means we will get 2b upon a. Let us take this as a m, and this is nothing but slope of tangent s. But what is the slope of normal then? Whatever the answer you are getting, you have to write up with opposite sign and reciprocal. Therefore, slope of the normal is equal to minus 1 upon m, that is minus 1 upon 2b upon a, that is minus a upon 2b. Now, one multiple choice question related with the same category, that means the slope of the tangent. So, I am solving all the similar questions in one side. So, if you do like this, the students will be perfect in the examples. So, related with the same question, that is question number 26 in exercise 6.3. The slope of the normal to the curve y is equal to 2x square plus 3 into sin x at x is equal to 0 is options multiple choice 3, 1 by 3, minus 3, minus 1 by 3. So, normal means first differentiate, that is everywhere first step. Y is equal to 2x square plus 3 sin x. Differentiating with respect to x. Dy upon dx is 4x plus 3 into cos x. And at x is equal to 0. Dy upon dx is, it is 0. 4 into 0 plus 3 into cos 0. What is cos 0? Cos 0 is 1. It is 3. When you differentiate and after differentiation, if you substitute the value, whatever the answer we are getting, we are calling it as a m and nothing but slope of the tangent. Slope of the tangent. But what is our question? Our question is slope of the normal. Therefore, slope of the normal. Students are already familiar how to write the slope of the normal. Whatever the answer, we have to write with opposite sign and reciprocal. That is minus 1 by 3. So, this is the slope of the normal. And I am doing all the sums, similar sums in one group, in one category, sums in one group. Why? Because I want to make you as a perfect. So, in this class, I solved all the questions related with the slope of the tangent and slope of the normal. In the next class, I will solve the question, find the points, the question related with find the points, and after that I will move to the equation of tangent and normal.